if you pay enough attention to enough Google news stories, there'll be some kind of crowding disaster after a concert, at a religious festival. I was about to say there was one just a couple weeks ago, but at any point in time, there's always one just a couple weeks ago. I'll point to one of them that was particularly jarring if you happen to be reading news in 1979. So, yeah, made it onto Rolling Stone. A rock concert seems straightforward. You show up, yell, band comes out, they stop, yell some more, they come back out, play 2 songs, that's it. Unfortunately, at this one, with The Who, well, it's got a formal-looking write-up because 11 people died. On the evening of December 3rd, 1979, in front of Cincinnati Riverfront Coliseum, this is not the giant football stadium, this is the smaller arena, amid a compacted crowd of thousands of anxious rock concert fans, 11 people died, nearly an equivalent number were injured. It's generally acknowledged that the crowd was not riotous or violent. At this point, this is, a very famous rock band. They're not drawing just a little kind of small circle of people ready for a small mosh pit experience. This is a show with, one of the 3 most famous rock bands of the world circa 1979. A pleasant suburban crowd shows up, and somehow there's 11 people killed. And I must admit, there probably been some before where people were using alcohol and drugs. But the question is why, of course, this event occurred at this particular concert, knowing that no one showed up at the concert deciding, hey, this would be a good time to trample on people on the way in. Obviously, it's not what people intended. I'm going to point to one other example that takes us to a form of explanation. And this is not an American one, and it's not so old. It's the Hajj. So every year, I looked up the numbers, it's something like 2 to 3 million people travel to Mecca for the Hajj. This picture happens to be, if you know this, of course, the Kaaba, which is circled 7 times by the pilgrim who makes the pilgrimage. The point is that during this event, which is not terribly long-lasting, there are 2 to 3 million people who are going through the same route. There are certain events that occur during the Hajj. This creates a serious crowding issue in which it was, as of 2006, not uncommon that despite the best intentions of everyone making the pilgrimage and the Saudi government arranging the facilities, it was not terribly uncommon for there to be a crowding disaster. If you've got 2 to 3 million people passing right through the same certain places over the span of a few days, there's considerable risk of crowding disaster. The Saudi government did something extremely wise. Oh, this is the news report that year. Actually, there were 15 more people. I believe it went to 360. So this is after 2006. I don't know if stampede, the Bloomberg news report, was the best word for that. But anyway, my apologies. That probably wasn't really the best way to depict the events, as we'll see. The Saudi government, and this is, you'll see this in chapter 12 of the book, did something extremely wise. They hired a team of people working with the government to analyze the dynamics of crowd disasters. It's a funny place to start, but the main person they contacted was not trained in social psychology, but is a physicist named Dirk Helbing, who uses mathematical and physical models to understand crowding in urban settings. At first, it sounds kind of funny. Why didn't they hire a psychologist? But there's something that happens here that was in the outline at the beginning, which is the value of analogies. It's so obvious in other courses, the person running the course doesn't even say it, but commonly, in other science courses, something's understood by way of some kind of analogy. So if you take a biology course and there's a story about evolution, at some point the person probably should be telling you that evolution is kind of like what happens on a farm. We understand what happens on a farm. The farmer has a bunch of these animals. Some of them are bigger and better than others. The farmer takes these good animals and breeds them together, and the next generation, they're better than the past generation, not through some miracle, but just because there was some breeding, and you do that a few times, and you got giant cattle or whatever you're breeding. Essentially what that says is there's an analogy between the farm and the real world of evolution. In physics, if you see one of these models of the atom, Bohr's model of the atom, it looks like a planetary system with electrons flying around. Obviously, the atom doesn't look exactly like that, and the physicists of the early 20th century didn't have pictures to see what the atom looked like, but that planetary model was a good analogy. Well, we kind of understood what a farm is like, and we kind of understand what the planets are like, and we'll use these as analogies. So here's the analogy. The analogy is that the flow of people through a space is at least in some way analogous to the flow of water through a space. So sometimes water flows smoothly, and sometimes it's turbulent, and there's a quick change, so you turn on your tub. Sometimes it flows smoothly, you turn it up a little higher, and there's too much volume for the space, and it becomes turbulent. Dirk Helbing realized that it might be possible to presume that people in a physical space are like fluids through a pipe, which then allows you, if you say that, to do something which you don't see too much of in psychology, so it's a funny place to start, yet it might be more valuable than you think, to run mathematical simulations. What he does is to run simulations that treat people as simulated points who move through a physical space using the already existing arithmetic of physical flow. Obviously, the formulas won't be on the exam. But there's an already existing physics of the dynamics of flows of liquid. And what he does is to develop these models of what would happen if you simply had individual units, the people, whose only goal is to get from here, the parking lot, to over there, the seats to see the Who concert. Or here, one place in Mecca, to over there, a site within the pilgrimage. The models at first look a little funny because there's no people, but they don't have to be. This is the value of the analogy. What he does, this is a model essentially of the Who concert. The Who concert problem wasn't just that the kids were waiting a long time or that a couple of them were drinking and had drugs. The problem was that the door was like that. There's a bunch of people here. This particular Colosseum had a door like that. If you put aside any goals and intentions and personality traits of the people and just treat them as physical objects with the goal of moving from left to right, then if you run one of these physics models, what happens is the thing becomes turbulent here. Too many people end up in the same place. They exceed the size of the doorway, and you can predict essentially mathematically that it's going to go turbulent. The beauty part of these simulations is that it allows this guy Dirk Helbing, to then predict, but to run the simulation and see what happens, predict how certain physical events added to the environment will reduce turbulence. Sometimes these are surprising. Rather than clearing up space, the simulations show that you can reduce crowding disasters by adding something. If you add a column, in a moment this becomes very real in a real example. He gets out of the world of the programs to the real case. If you add a column, you reduce the flow through the doorway because people have to go around the column. The prediction of the model is if you add the column, everything should be fine. Another thing you might think, well, you widen the space, that's good. Sometimes widening the space is bad. If you can't widen the space all the way through, then what happens is you widen the space, and then next time it goes back to normal, it's too much crowding. So what happens is the Saudi government hires this person to redesign one of the major entryways, which I'll have a picture of in a moment, during the pilgrimage in Mecca, and then comes back the next year and sees what happens. So this may be the singularly largest success story of somebody running some social psychology kind of thing, and immediately having it implemented on a huge scale that affects, obviously, pilgrimage of 2 to 3 million people. In that paper I put up, Dirk Helbing and colleagues make specific recommendations for changing, what's this bridge, the John Murat Bridge, changing its original shape, a straight line, into an elongated shape that also has these, oh, it's easier to see it in the actual picture, these columns in the middle. So this is his mock-up of a bridge based on his simulations. This is Google Earth. This is the actual bridge. So in Mecca, an ancient city that's been modernized as well, they've got this bridge from outer space with these funny shapes and these elongated things. As people go from here to here, you'd think these would get in the way and make matters worse, but just like the simulation, by adding these things to the bridge, it works in some. In that next year, 2007, there's an easy flow of people where there previously have been disasters, and if you go to the web page on Wikipedia, which isn't quite as bad information, it's often, of course, actually very good, even if another class says, for God's sakes, don't use Wikipedia. Obviously, information-wise, it's often quite accurate. They actually do have crowding incidents at or during the Hajj web page, and the incidents stop at 2006. So there's a disaster in 94, 98, 2001, 2003, 2004, 2006, and then they totally stop. There's no more disasters because of the redesign of the bridge. So this guy's work was extremely successful. The points here, the social psychology points, of course, no one went on the Hajj hoping to be part of a disaster in which they step on 8 people on their way to a holy site. So you can't possibly, it's a complete error to explain the people's behavior in terms of the personality qualities of the individuals. The explanation has to be in terms of the crowd as a whole. In this case, literally the physical properties of the crowd, which make it impossible to fit too many people in one small space. Not to go into the unfortunate details, but often in these events, people are not stampeded. That's why this was an error in the news report. The crowding becomes so severe that people can't breathe. I mean, in super crowds, you can't just change the capacity of your chest cavity and lungs to breathe, and people suffocate, not are stampeded. That's the crowding problem. So, as lesson number 1 in social psychology, in this case, there's a social behavior, something people do in the social world, but it can't be explained by anything that says they wanted to do this. In this case, the explanation is they're a unit in a big system, and if you were put in that system, there was no way at certain points of avoiding being part of a crowding disaster. And just to point it out again, it also shows the value of analogies. A couple of times in this course, we'll see a big analogy. In this case, crowd like a fluid. In the case of personality theory, Freud is going to suggest the mind works like an energy system, like a car engine. In the study of memory, we're going to suggest that in some ways the human mind works like a computer system, which has different forms of memory storage. A bunch of times in this course, there'll be some analogy that's obviously imperfect, but nonetheless buys you something scientifically.